81. Accuracy. The most common metric for classification, the percentage of correct predictions. If a model is correct 95 out of 100 times, its accuracy is 95%. Can be misleading when dealing with imbalanced datasets. High accuracy alone does not mean a model is good or useful. It's a starting point for evaluation, but you often need more nuanced metrics. 82. Precision. A metric that measures what proportion of positive predictions were actually correct. Of all the emails your model flagged as spam, how many actually were spam? High precision means the model has a low false positive rate. Important when the cost of a false positive is high, e.g., a medical diagnosis. It answers the question, when my model says yes, how often is it right? 83. Recall. Sensitivity. A metric that measures what proportion of actual positives were correctly identified. Of all the actual spam emails, how many did your model correctly catch? High recall means the model has a low false negative rate. Important when the cost of a false negative is high, e.g., missing a disease. It answers the question, of all the things I should have found, how many did I find? 84. F1 score. The harmonic mean of precision and recall, providing a single score that balances both. It's a useful metric when you need a balance between precision and recall. A good F1 score means you have low false positives and low false negatives. Ranges from 0, worst, to 1, best. Often used when you have an imbalanced class distribution. 85. Confusion matrix. A table that summarizes the performance of a classification model. It shows the number of true positives, true negatives, false positives, and false negatives. Provides a detailed breakdown of a model's errors. The source for calculating accuracy, precision, recall, and F1 score. A fundamental tool for understanding the performance of a classifier. 86. ROC curve. An AUC plot that shows a classifier's performance across all classification thresholds. The AUC, area under the curve, provides a single number to summarize its performance. A model with an AUC of 1.0 is perfect, 0.5 is no better than random guessing. Helps you choose the best threshold for your specific problem. A powerful tool for comparing the performance of different classification models. 87. Mean absolute error, MAE. A common metric for regression. The average absolute difference between predictions and actual values. It's easy to understand and interpret in the original units of the target. If you're predicting prices, the MAE is the average dollar amount you are off by. It gives a straightforward measure of the average error magnitude. It's less sensitive to outliers than root mean squared error. 88. Root mean squared error, RMSE, a regression metric that measures the square root of the average squared errors. It penalizes large errors more heavily than MAE does. Also in the same units as the target variable, making it interpretable. One of the most widely used metrics for regression tasks. A lower RMSE indicates a better fit of the model to the data. 89. A/B testing. A method of comparing two versions of a system, A and B, to see which performs better. Companies use it to test if a new recommendation algorithm increases user clicks. It's a controlled experiment to measure the real-world impact of a new model. The gold standard for evaluating model performance in a live production environment. Ensures that a new model actually improves business outcomes before full rollout.